Welcome to Math Contest Drills for Filipino Kids. In this presentation, let us show the solution to the 2016 Elimination Round for Grade 10. This is part 1 of 2 parts. Let's have the instruction. Give all fractions in lowest terms and all equations of the lines in the form ax plus by equals c, where a, b, and c are relatively prime integers with a greater than 0. Question number 1. Find the value of the square root of x plus the square root of 14 minus x when x equals negative 2. The solution is just to substitute x is equal to negative 2 to the expression. So we have the square root of negative 2 plus the square root of 14 minus negative 2. Then we have the square root of negative 2 plus the square root of 16. The square root of 16 is 4. So we have negative 2 plus 4. Then this is the square root of 2. Next number. Find the area of the triangle formed by the coordinate axis and the line 3x plus 2y is equal to 6. Here is our solution. If we get the intercepts of the given line, when x is equal to 0, we have 3 times 0 plus 2y is equal to 6. Then we have 2y is equal to 6. Dividing both sides by 2, we get the y-intercept as 0, 3. Then the height of the triangle formed will be 3 units. When y is equal to 0, we'll get the x-intercept. So we have 3x plus 2 times 0 is equal to 6. 2 times 0 is 0. Then we have 3x is equal to 6. So we have x is equal to 2 after dividing both sides by 3. Then the base of the triangle formed is 2 units. So the area is equal to 1/2 the base times the height. And this is equal to 3. So the area of the triangle is 3 square units. Next number. A sequence is defined by a sub n is equal to 3a sub n minus 1 plus 2 for n is greater than or equal to 2, where a sub 1 is equal to 1. What is a sub 4? Here's our solution. First, let us get a sub 2. Then we have 3 times a sub 2 minus 1 is a sub 1. Then that will be 1 plus 2. And this is equal to 9. Then we'll get a sub 3. That will be 3 times a sub 3 minus 1 is a sub 2. Then that is 9 plus 2. Then this is equal to 3 times 11, 33. Now we get a sub 4. That will be 3 times a sub 4 minus 1. And that is a sub 3, which is 33, plus 2. So we have 35 times 3. A sub 4 is equal to 105. Question number 4. Christa leaves town A after traveling 12 kilometers. She reaches town B at 2 p.m. Then she drives at a constant speed and passes town C 40 kilometers from town B at 2:50 p.m. Find the function d of t that models the distance in kilometers. She has traveled from town A 10 minutes after 2 p.m. Here is our solution. Christa reaches town B, which is 12 kilometers from town A at 2 p.m. Then from town B to town C, that is 40 kilometers. And she reached town C at 2:50 p.m. So that is 50 minutes. The constant speed mentioned in the problem is the distance 40 kilometers in 50 minutes, and this is equal to 0.8 kilometers per minute. Hence, from town A, the function d of t is equal to 0.8 times time, t in minutes, plus 12 kilometers. That's the distance from town A to town B. Problem number 5. What is the largest negative integer that satisfies the inequality? Absolute value of 3x plus 2 is greater than 4. Here is our solution. Let us solve the absolute value of 3x plus 2 is greater than 4 for x. Then 3x plus 2 is greater than 4, or 3x plus 2 is less than negative 4. From this inequality, let us subtract 2 from both sides. We get 3x is less than negative 4 minus 2, that's negative 6. Then we divide both sides by 3, we get x is less than negative 2. Therefore, the largest negative integer that satisfies the inequality is negative 3. Problem number 6. A person has 2 parents, 4 grandparents, 8 great-grandparents, and so on. How many ancestors does a person have 10 generations back? Here's our solution. The problem illustrates a geometric progression, and talking about ancestors, a sub 1 for a person has 2 parents. Then a sub 2 is equal to 4. A sub 3 is equal to 8. From here, we get the common ratio as equal to 2. Asking for the number of ancestors a person have 10 generations back, we are looking for S of 10. Solving for S sub 10, we have A sub 1 times the quantity 1 minus the common ratio raised to n, that is 10, over 1 minus the common ratio. So we have 2 times 1 minus 2 raised to 10 is 1024 over negative 1. 1 minus 1024 is negative 1023. So that is negative 2046 over negative 1. Therefore, S of 10, or the answer, is 2046. Number 7. In triangle ABC, angle B is twice angle A, and angle C is 3 times as large as angle B. Find the measure of angle C. Here's our solution. Let x be equal to the measure of angle A. Then the measure of angle B is equal to 2x. And the measure of angle C is equal to 3 times the measure of angle B, which is 2x. We know that the sum of the interior angles of a triangle is 180 degrees. Therefore, angle A plus angle B plus angle C is equal to 180. Then we have x plus 2x plus 6x is equal to 180. This is 9x equals 180. Then x is equal to 20. Therefore, the measure of angle C is 3 times 40. This is equal to 120 degrees. Problem number 8. If x is greater than or equal to negative 3 but less than or equal to 0, find the minimum value of f of x is equal to x squared plus 4x. Here is our solution. F of x is equal to x squared plus 4x is a parabola that opens upward. Hence, let us translate the equation of the parabola in its vertex form. So we have f of x is equal to x squared plus 4x. Completing the square, we have plus 4 minus 4. Then the vertex form of this equation of the parabola is x plus 2 squared minus 4. And the vertex of the parabola is at negative 2, negative 4. Hence, the minimum value of the function is negative 4, that is when x is equal to negative 2, and negative 2 is within the range negative 3, 0, or within the interval negative 3, 0. Question number 9. The ninth and the 11th terms of an arithmetic sequence are 28 and 45 respectively. What is its 12th term? Here is our suggested solution. 28 is the ninth term of an arithmetic sequence. Then we have 28 is equal to a sub 1 plus 8 times the common difference. 8 is 9 minus 1. And 45 is the 11th term, so we have 45 is equal to a sub 1 plus 10 times the common difference. 10 is from 11 minus 1. If we subtract these two equations term-wise, we'll get negative 17 is equal to negative 2d. Then the common difference is equal to 17 over 2. Solving for a sub 1, let us use 28 is equal to a sub 1 plus 8 times 17 over 2. And this is equal to 28 equals a sub 1 plus 4 times 17, that is 68. Therefore, a sub 1 is equal to 28 minus 68, that's negative 40. Solving for the 12th term, we have negative 40 plus 11 times 17 over 2. So we have negative 40 plus 11 times 17 is 187 over 2. 187 over 2 is 93.5. So we have negative 40 plus 93.5. Then a sub 12 is 93.5 minus 40. That is 53.5. Number 10. Perform the indicated operations and simplify. Here is our solution. We have 2 over x plus 3 over x minus 1 minus 4 over x squared minus x is x times x minus 1. So our LCD is x times x minus 1. Then rewriting the fractions, we have x times x minus 1 divided by x is x minus 1. So we have 2 times x minus 1. The LCD divided by x minus 1 is x. Then we have 3x minus 4. So we have 2x minus 2 plus 3x minus 4 over x times x minus 1. 2x plus 3x is 5x. Negative 2 minus 4 is negative 6 over x times x minus 1. Or 5x minus 6 over x squared minus x. Question number 11. Find the range of the function f of x is equal to the absolute value of 2x plus 1. For the absolute value function, we have the range, or we have all values of y, element of the real number, such that y is greater than or equal to 0, since the value of f of x will always be non-negative. Question number 12. Find the value of x minus the quantity x minus x raised to negative 1, closed quantity raised to negative 1, raised to negative 1 when x is equal to 2. For our solution, let us just substitute x is equal to 2 to the expression. Then we have 2 minus 2 raised to negative 1. Then we have the exponent negative 1. Then we have another exponent negative 1. So we have 2 minus 1 half raised to negative 1. And then we have raised to negative 1. 2 minus 1 half is 3 halves. So we have 2 minus 3 halves raised to negative 1 is 2/3. Then we have raised to negative 1. 2 minus 2/3 is 6 over 3 minus 2/3. And then we have raised to negative 1. 6/3 minus 2/3 is 4/3 raised to negative 1. Then this is equal to 3 over 4. Number 13. Find the equation in the form ax plus by equals c of the line through the point 5, 2 that is parallel to the line 4x plus 6y plus 5 equals 0. Since the two lines are parallel, let us just rewrite the given line in its standard form. That will be 4x plus 6y equals negative 5. Then the line parallel to this will be 4x plus 6y equals, let us just substitute the ordered pair 5, 2 to the left hand side of the equation. That will be 4 times 5 plus 6 times 2. This is equal to 32. Then we have 4x plus 6y equals 32, or 2x plus 3y is equal to 16. Number 14. In triangle ABC, angle B is 90 degrees and angle ACB is 28 degrees. D is the midpoint of AC. What is angle BDC? Here is our solution. We have triangle ABC and angle B is 90 degrees. we have angle C equals 28 degrees. Since D is the midpoint to the hypotenuse, then we have AD is congruent to DC, congruent to BD. Then we're looking for angle BDC, that's angle D. Triangle BDC is an isosceles triangle. Therefore, angle BDC is equal to 180 minus 2 times angle ACB, which is 28 degrees. We multiply 28 degrees by 2 since angle C is congruent to angle DBC. So, angle BDC is equal to 180 minus 56, and this is 124 degrees. Number 15. Find all solutions to the system 2x plus y equals 1 and 3x plus 4y equals 14. Here is our suggested solution. Let us use the substitution method. Let 2x plus y equals 1 be our equation number 1, and 3x plus 4y equals 14 be our equation number 2. Then, from equation number 1, we have y is equal to 1 minus 2x. Let us substitute the value of y to equation 2. Then we have 3x plus 4y, which is 1 minus 2x, equals 14. Then let us solve for x. 3x plus 4 minus 8x is equal to 14. 3x minus 8x is negative 5x. Subtracting 4 from both sides of the equation, we have 14 minus 4, that's 10. Then x is equal to negative 2, dividing both sides of this resulting equation by negative 5. Let us solve for the value of y. Y will be equal to 1 minus 2 times negative 2. And this is equal to 1 minus 2 times negative 2, that is 1 plus 4. Then y is equal to 5. Hence, the solution to the system is the ordered pair negative 2, 5. Problem number 16. If f of 2x minus 1 equals x, what is f of 2? Number 16 is an example of a composition of function. So here's our suggested solution. Let g of x be equal to 2x minus 1. Then f of g of x is equal to x. From g of x is equal to 2x minus 1, let us solve for x. We have g of x plus 1 is equal to 2x. Therefore, x is equal to g of x plus 1 over 2. Since f of g of x is equal to x, we have f of g of x is equal to g of x plus 1 over 2. Then let us replace g of x with x. So we have f of x is equal to x plus 1 over 2. Then solving for f of 2, we have f of 2 is equal to 2 plus 1 over 2. 2 plus 1 is 3. Then f of 2 is 3 halves. Number 17. What is the quotient when 3x to the 5th plus 5x to the 4th power minus 4x cubed plus 7x plus 3 is divided by x plus 2? For our suggested solution, let us use the synthetic division. Hence, let us get the coefficients of the dividend. We have 3, 5, negative 4. Since there is no term with x squared as the variable, then we have 0, 7, and then 3. The divisor is x plus 2, then we have negative 2. Let us proceed with synthetic division. Let's bring down 3 times negative 2 is negative 6. Then we add negative 1 times negative 2 is 2. Negative 2 times negative 2 is 4. So we have 4. 4 times negative 2 is negative 8. Then we have negative 1. Negative 1 times negative 2 is 2. So we have 5. Hence, the quotient is 3x to the 4th power, that is 1 degree less than the dividend, minus x cubed minus 2x squared plus 4x minus 1. And then the remainder is 5, so we have 5 over x plus 2. Since we're just asked to give the quotient, then the quotient is 3x to the 4th power minus x cubed minus 2x squared plus 4x minus 1. Problem number 18. A man is walking away from a lamppost with a light source 6 meters above the ground. The man is 2 meters tall. How long is his shadow when he is 110 meters from the lamppost? For our suggested solution, let us draw a representation of the problem which forms a right triangle, where the height of this right triangle is the lamppost, where the light source is 6 meters from the ground. Let us have the base of the right triangle as the ground. And then we have a man standing 110 meters away from the lamppost. And the man is 2 meters in height, so this is equal to 2. The distance between the lamppost and the man is 110 meters. Let x be the shadow cast by the man. So we have similar right triangles. Then we have the height of the bigger triangle over the base, which is 110 plus x, is equal to the ratio between the height and the base of the smaller triangle. That's the height of the man as the height of that smaller triangle over x. Cross multiplying, we have 6x is equal to 220 plus 2x. So we have 4x, subtracting 2x from both sides, is equal to 220. Then x is equal to 55. Therefore, the shadow cast by the man when he is 110 meters away from the lamppost is 55 meters. Number 19. Find the length of the shorter segment made on side AB of triangle ABC by the bisector of angle C. If AB equals 20 centimeters, AC equals 12 centimeters, and BC equals 18 centimeters. For our suggested solution, again, let us visualize the triangle ABC. The shortest segment is AC and the longest is AB. So we have ABC. AC is 12 centimeters, BC is 18, and AB is 20 centimeters. We're looking for the length of the shorter segment made on side AB by the bisector of angle C. So angle C is bisected. Let the shorter segment be x and the longer segment be 20, since AB is 20 centimeters long. 20 minus x. From the angle bisector theorem, we can write the equation 12 over x is equal to 18 over 20 minus x. Cross multiplying, we have 12 times 20 minus x. That is 240 minus 12x. And then on the right hand side, 18x. So we have 240 is equal to 30x, adding 12x to both sides. And then we divide by 30, we have x is equal to 8. So the shortest segment made on side AB is 8 centimeters. Number 20. How many different 3-digit numbers less than 300 can be formed with the digits 1, 2, 3, and 5 if repetition of digits is not allowed? For our suggested solution, let us have the 3-digit numbers that can be formed by the digits 1, 2, 3, and 5, considering that the 3-digit numbers are less than 300. So let us have 1 as the first digit, then we have 2, 3, and 5 as the choices for the second digit, then we have 3 choices. Since repetition is not allowed for the third digit, we will have only 2 choices. So we can have 6 3-digit numbers less than 300 that begins with 1 as the first digit. Next, let us have 2 as the first digit. Again, we have 3 choices for the second digit and 2 choices for the third digit. This is 6 numbers. Since we're looking for numbers less than 300, any number that starts with 3 will be greater than 300. In total, we only have 12 3-digit numbers less than 300. Number 21. Factor completely the expression x cubed minus 7x plus 6. For our suggested solution, let us use the rational root theorem. Since the leading term is x cubed, so the leading coefficient is 1, and the constant term is 6, so we have the possible values for x as positive, negative, 1, 2, 3, and 6. Let's use synthetic division. We have 1, 0, negative 7, and then 6. Let's begin with positive 1. So we have 1 times 1 is 1 plus 0. Negative 6 times 1 is negative 6 plus 6 is 0. Therefore, 1 is one of the roots, and then we have x squared plus x minus 6. We can factor this as x plus 3 times x minus 2. Since 1 is also one of the roots, then we have x minus 1 times x plus 3 times x minus 2. Problem number 22. An integer between 1 and 10,000 inclusive is selected at random. What is the probability that it is a perfect square? Here is our suggested solution. From 1 to 10,000, the lowest perfect square number is 1. That is 1 times 1. And the largest perfect square number is 10,000. That is 100 times 100. Therefore, there are 100 perfect square numbers between 1 and 10,000 inclusive. So, the probability that the integer is a perfect square is 100 over 10,000. And this is equal to 1 over 100. Problem number 23. If a chord 24 centimeters long is 5 centimeters from the center of a circle, how long is a chord 10 centimeters from the center? For our solution, let us draw a diagram for the problem. Let us have a circle and say that a segment or a chord is 24 centimeters long when it is 5 centimeters away from the center. We know that the chord is perpendicular to the line containing the radius, therefore we have that 24 centimeter chord bisected. Then half of the chord is 12 centimeters and the length or the distance between the center of the circle and the chord is 5 centimeters. Let R be the radius. So the radius, the distance between the chord and half the chord forms a right triangle. From Pythagorean triples, we say that R is equal to 13. That is the square root of 12 squared plus 5 squared. This time, let us draw the chord that is 10 centimeters away from the center. Also, this chord is perpendicular to the line containing the radius, and the distance is 10. Since the radius is 13 centimeters, then we can get half the chord by using Pythagorean theorem, and let that be x. So x is equal to the square root of 13 squared minus 10 squared. This is equal to the square root of 169, that's 13 squared, minus 100. So this is equal to the square root of 69. Since this is just half the chord, then the chord is twice this length. Since the chord is bisected by the line containing the radius, the answer is 2 square root of 69 centimeters. Problem number 24. Pipes are being stored in a pile with 25 pipes in the first layer, 24 in the second, and so on. If there are 12 layers, how many pipes does the pile contain? Here's our suggested solution. The problem illustrates an arithmetic series. Since we're looking for the sum of the pipes in the pile, then we will use the formula for the sum of the first n terms of an arithmetic series, that's S sub n is equal to n over 2 times 2a sub 1 plus n minus 1 times d. We're going to use this formula since we do not know a sub n, or the number of pipes in the 12th layer. From the problem, n is equal to 12, a sub 1 is 25, and the common difference is negative 1. Since each layer is 1 less than the previous layer. So we have S sub 12 is equal to 12 over 2 times 25 plus 11 times negative 1. 12 over 2 is 6 times 2 times 25 is 50, and 11 times negative 1 is negative 11. So we have 6 times 39. 6 times 39 is 6 times 30 plus 6 times 9, that's 180, plus 54. So we have a total of 234 pipes in the pile. Last question for part 1. Find the solution set of the inequality x squared is less than 5x minus 6. Here's our solution. Let us write the inequality with the right-hand side 0. So we have x squared minus 5x plus 6 is less than 0. Factoring the trinomial on the left-hand side of the inequality, we have x minus 2 times x minus 3, then this is less than 0. The smaller root on the left-hand side is 2, and the bigger root is 3. Therefore, for this inequality, x is in the interval 2, 3. That will be all. Thank you for watching. Please subscribe for more math contest drills for Filipino kids videos.